Okay, we're going to be solving specific examples from differential equations because every one of these today has an initial condition. Right, so we're going to be able to figure out exactly what that c value is, the y-intercept of your function, when we're given this initial condition. It's pretty okay stuff. So remember, there were 3 steps to solving a differential equation. First, you want to separate your dy's and your x's. So you separate y and dy, get them together, and you separate x and dx and get those together. Okay, so you separate your variables, okay, and then you integrate both sides and take the antiderivatives, and then you use your initial condition to solve for c. So this is where this comes in. You take your x and your y and you figure out what your c value is. That's an O. And then the last thing you want to do, if it's not already done, is solve for y. Okay, and this is where we're going to have to make some choices as to which of our equation it's going to be. Okay, so we'll have a couple of examples of that in here also. Okay, so first of all, we're going to separate. So we're going to move our dx by multiplying over to this side. All right, so dy equals 6x squared plus 6x plus 2 dx, right? We're taking the derivative, the anti of all of this stuff. So there we have separated your variables. And now we integrate both sides, because what you do to one side in math, you have to do to the other. So we'll integrate here. And the integral of y is just y, or rather, sorry, the integral of dy is y. There's one of them. And over here we have x to the cubed, right, divided by 3. So this becomes 2x cubed plus 3x squared as the antiderivative of 6x plus 2x as the antiderivative of 2 plus c. So now that we have taken the antiderivative, we're going to replace y with 2, right? So y is 2, and x is -1. So -1 goes here, -1 goes there, -1 goes everywhere you're going to see an x. So 2x cubed plus 3 times -1 squared plus 2 times -1 plus c. So it turns into a fairly nice, or maybe it's not nice, I don't know. You can decide whether or not it's niceness. Let's see. 2 and 2 is 4, -1. So we have a c value of 3. Okay, so the last thing to do is replace your c value up here with 3, and we have solved our differential equation. Plus 3. Okay? Separate, integrate, plug in your initial condition, solve for y. So let's check out this next one over here, which looks pretty complicated, but we're going to simplify things simply by moving our 2 root x up to the numerator as a negative power. Okay, so we're going to have 1 plus 12 x to the 3/2 times 2x to the -1/2. Okay, so we change our rational into a polynomial by taking your negative exponent and raising it to the top. Okay, so now we're going to distribute. We're going to multiply this stuff in here. And then at the same time at the end, I'm going to multiply by dx. So let's just do this. dy equals 2x to the -1/2 plus 24x to the 3/2 minus 1/2 is 2/2. 2 divided by 2 is 1. And we're going to have dx. Okay, so we have separated our variables when I multiply both sides by dx. So now we're going to integrate. can take the integral of both sides. And the integral of dy is just y. And we're going to add 1 to our power, making it x to the positive 1/2. And we're going to divide that by 1/2 also. Plus 12x to the squared power plus c. So let's do some simplifying here before we do our substitution. So 1/2, 2 divided by 1/2 is the same as 2 times 2. So that's 4. The 1/2 power is the square root. So it might be easier to algebra with my square root than with a 1/2 power. And then plus c. So I have an initial condition of x equals 0. So I'm going to put 0 in for x. Well, that's pretty easy. And a y value of 2. So 4 times root 0 is 0. 12 times 0 squared is 0. So c equals 2. Well, that wasn't very exciting. But that's okay. Math doesn't always have to be exciting. So 4 root x plus 12x squared plus 2 becomes your final differential equation solution. Okay, here on number 3, our first step of separating means we're going to cross multiply. Okay, and we will have 2y dy equals parentheses x squared plus 2x dx. Okay, it's really nice when we have two equal fractions. We just have to cross multiply, and we're basically done with your separation. So now we can get to integrating both sides. So the integral of 2y is 2y squared divided by 2, which is just y squared. And the integral of x squared is 1/3 of x cubed, or if you want x cubed over 3, plus x squared plus c. So that is your antiderivative. Y squared equals 1/3 x squared, x cubed, plus x squared plus c. So now let's plug in our 2 for y. So 2 comes over here, and 0 everywhere for x. Okay, and it looks like, once again, all of our x's are zeros, and 2 squared is 4, so 4 is equal to your c value. So we have y squared equals 1/3 of x cubed plus x squared plus 4. Okay, so there's one more step now, because I have y to the second power is to square root both sides. And in algebra, when you square root things, you get positives and negatives. So here's where we're going to have to make a choice. Okay? Remember, based upon your initial condition, when f was 0, y was 2. So we have to check and see if y is positive 1/3 of x cubed plus x squared plus 4, or is y the negative part? So we're talking about the top half of this semicircle or the bottom half. I don't even know if it's a semicircle. I won't even say that because I don't know. So when you plug in 0, right, so x is 0. If you plug a 0 in here and a 0 in here, we get y equals the square root of 4, which is 2. And if you plug a 0 in here and a 0, we get y equals negative square root of 4, which is negative 2. Okay, so seeing that, right, we don't want to have a negative 2 when you plug in 0. We want to have the positive 2 version. So in other words, y does not equal plus or minus, but rather just plus. Okay, so whenever we have this business of having an option, a positive or a negative, you have to make sure that when you plug x into each of the functions, that you get out the specific y from your initial condition. Okay, so if y were negative 2 at the top, then you would have the negative part of the answer as your equation. Okay, so that's the last part, is to solve for y and make a choice as to which one works best. Okay, so one more example. Let's see what we get. So this one, when we solve for c and plug back in, okay, we get the square root, so plus and minus root of half x squared plus 2x plus 6.5. So if you plug the positive side, we get positive 3 as your square root. And if you use the negative one, we get a negative 3. And looking at our initial condition, we want y to be negative 3, which means the negative root is going to be your answer for this differential equation. Y equals negative square root half x squared plus 2x plus 6.5. Okay, so the initial condition will tell you whether you have a positive or a negative as your final answer. So make sure that you're checking whenever we square root that you have a plus and a minus, and some other things also, which we're going to tackle here in a second, about figuring out whether we have one or the other. Okay, so here are two more examples for us to do, to have a look at, and see what type of an equation we get here on number 5. Okay, so when we separate number 5, right, the dx comes over here, but we're going to divide both sides by y minus 2. So on the left we get dy over y minus 2, and on the right we have x to the 4th dx. Okay, so we're going to integrate both sides and take the antiderivative. So the antiderivative of dy over y minus 2 is natural log of y minus 2 in absolute value. Okay, so when we're taking an integral and we get a natural log, we make sure we have the absolute value of that function. And here we have x to the 5th plus c, 1/5 x to the 5th plus c. So now our initial condition, right, we have an x of 0 and a y of 0. So you plug in 0 here and 0 there. So let's figure out what we have on the left side. We have natural log of absolute value negative 2 equals c. So c is just the natural log of 2. Okay, so now we can rewrite our equation as natural log y minus 2, still an absolute value, equals 1/5 of x to the 5th plus natural log 2. So we separate, we integrate, we solve for c, and now we have to solve this equation for y. So we're going to do a lot of some algebra or pre-calculus style stuff here. So how do we get rid of a natural log? Well, we make sure to raise it under a base of e. So we make them into exponents, because e raised to the natural log cancels out. Okay, and we're left with absolute value of y minus 2 equals e to the 1/5 of x to the 5th plus the natural log of 2. So now we're going to use a little bit of pre-calculus again on this bit. Okay, if we have a plus in your exponent, we can change that into e to the fraction 1/5 x to the 5th times e to the natural log of 2. Okay, we can have two bases that are multiplied together when you have an exponent that is added. Okay, and that's pretty wonderful, because e raised to the natural log again is just is an identity, so it gives us a 2 e to the 1/5 x to the 5th equals the absolute value of y minus 2. Okay, so we're not done yet because we haven't solved this for y. It's still an absolute value. So absolute values can either be positive or they can be negative. So y minus 2 can equal positive 2e to the 1/5 x to the 5th, or y minus 2 could be negative 2e to the 1/5 x to the 5th. Okay, so when we have an absolute value, we split it into two equations, one of which is positive and the other of which is negative. So when we add 2 to both sides, we get 2 plus 2e to the 1/5 x to the 5th, or we get 2 minus 2e to the 1/5 x to the 5th. So which one is it? Is it going to be the left equation with a plus, or is it going to be the right equation with a minus? Okay, the only way we can tell is by once again looking at your initial condition. When x is 0, we want to have a y answer of 0. So let's come back and we'll plug in 0 and see what we get. Okay, so if we plug in 0 here, that's 2 times e to the 0. E to the 0 is 1. So if you have x equals 0, then y is 4 if it's plus 2e to the 1/5. And then this becomes a 0. E to the 0 is 1. 2 minus 2 times 1 is 0. So this equation gives us the correct y value when you plug in an x of 0. So it's not 2 plus 2, but rather 2 minus 2e to the 1/5 x raised to the 5th power. Okay, so whenever we have a natural log or we have a square root that's plus and minus, you have to check and see which one gives you the correct y value when you plug in your initial condition. Okay, that initial condition has to be met. So we check it and see which one's going to be met. Okay, make sure that you do that with all these problems whenever we're taking a natural log or it has an absolute value, or you're taking a positive and negative square root. You have to check and make sure that your initial condition is met.